Okay, one of my viewers asked about IGBTs and how you would test for the leakage currents on an IGBT. Normally, the mode of failure for an IGBT is simply a short from collector to emitter. But if you're really interested in checking leakage currents, you really can't do it with just a plain old multimeter DMM, because the operating voltages for the IGBT are so large. Usually the one I'm going to test today is 1200 volts, that you've got to get it at least some type of a high voltage to be able to test for leakage. So what you can do if you don't have a high voltage power supply is simply hook a bunch of 9-volt batteries in series. So right here I have 6, 7, 8, 9, 10, 11, 12 9-volt batteries in series. So I have well over 100 volts here. And I put a little lamp here. This is a 40 watt lamp, but you can use anything between 20 and 60 watts. You're not going to be able to drive it for very long with these batteries, but you can. You need a load, so this is providing that load. So if I take this and hook it directly up to the battery, this lamp, you'll notice that I get it to turn on. So I'm going to hook this up to my IGBT. This is a 1200 volt 5 amp IGBT. I've got the collector hooked to the positive side of my 9-volt battery here, my 9-volt battery bank, and I've got the emitter hooked to negative side of the power supply. It turns out you can get the IGBT to work whether the lamp is in the emitter side of the circuit or the collector side of the circuit. And let's go ahead and test it just to make sure everything's working good, that we got the right kind of connection. So I'm going to use a 9-volt battery here because I don't want to exceed the gate voltage on the IGBT. This one has a plus or minus 20 volt range on the gate, so I'm just going to use a 9-volt battery to trigger it. And the way I'm going to do that is just hook the emitter of the IGBT to the negative side of this battery, and I'm going to use the positive terminal of the 9-volt battery to trigger the IGBT gate. And so there we go. And notice it stays on, and that's because it's accumulated some charge on the gate and it's holding that charge. So I really have to leak that charge off in order to get it to turn off again. So one way to do that is I'll just use one of these battery clips, and right now what I've got is the emitter. If I touch the emitter to the gate, I can leak off that charge. So we know the IGBT is working, doing what it's supposed to do. We were able to turn it on with that 9-volt battery. More importantly, it stayed on because it accumulated this charge. So what we want to do to test the leakage is to take our meter, and we're going to put it on the lowest current we can measure. It's going to be better to start off with a higher current, but we'll eventually work our way down to the lowest current. And this is going to check for leakage. So what we're going to do here is I'm going to hook my positive side of the IGBT to the meter. So now I've got the meter in series taking a current measurement here. And really important that you don't trigger the IGBT on during this test by touching the gate or anything. So right now, no leakage at 200 milliamps full scale, no leakage at 20 milliamps full scale. It looks like it's flickering about 1 milliamp when I got it on the well, actually about it was a 0.001 milliamps when I had it on the 2 milliamp scale. Put it on the microamp scale, nothing. That's the 200 microamp scale, I'm sorry. 20 microamp scale, it looks like we probably get about 0.01 microamps. So virtually nothing on the leakage here. And that's at 100 volts, so that's a pretty good indication that this IGBT is functioning normally, not leaking. And as I said, it's not a normal mode of failure for an IGBT to necessarily leak. The only DMM check, or the digital multimeter check, you can do on one for the most part is to check for a short between the collector and the emitter. And so if you use your meter and find out you've got a short, that's about all you can do with a DMM. So here's the circuit, and all I did here was I hooked these 9-volt batteries in series. There's my lamp, and this shows the lamp on the collector side, but for the video I had the lamp on the emitter side. It doesn't really matter, it works either way. So here's my IGBT load side circuit, and here's the side that I use with my 9-volt battery here. Once the negative side of the battery hooked to the emitter, and the positive side was hooked to a test lead that I could touch to the gate to turn it on and make sure the turn-on characteristics of the IGBT were okay. So that's it. A very cheap way to test an IGBT under fairly high voltage. And by the way, you can take 9-volt batteries and hook as many of them as you want together to get a nice DC power source. The current draw is not that great, but for high voltage circuits, DC, this is a great way to do it. I've been able to hook these together and get in excess of 300 volts doing this for certain experiments. So good luck testing IGBTs. See you later.